Dear colleagues, it seems time to start, so maybe we start according to the schedule, and after that Lou joined us. So it's my pleasure to introduce the first speaker for today, Professor Akio Kawauchi, and he will tell us about the topic which you can read in the title. Also, I suppose Akio you will share the screen. So please.
Okay.
Okay, so please welcome.
It's okay, start?
Yeah, please start. Yes,
okay.
Yes. I think according to the schedule, we can start.
Okay, okay.
If somebody late, we have a recording, so it's not a problem.
So I will talk about surface link theory. It's a yes. Surface link is a closed-oriented surface F, smoothly embedded in 4 space R4, and the surface node if F is connected. So standard terminology, two surface links F and F dash are equivalent. If there is an orientation preserving diffeomorphism F of R4, sending F to F dash, orientation preserving, and surface link F is trivial if F is the boundary of disjoint handle bodies smoothly embedded in R4. In that case, trivial surface link is unique up to equivalence. So two handle on a surface link F is an embedded two handle D cross I on F with D core disk, such that the intersection of D cross I and F is just annulus, attaching annulus, boundary D cross I. Okay? And I denote a closed interval containing 0, and D cross 0 is identified with D. And the F D surgery, okay, 200 surgery of F is denoted by F D cross I. And if F is immersed disk, then call it an immersed two-handle. So two handles, D cross I and E cross I on F are equivalent. If there is an equivalence F, sending F to itself, such that the restriction to F, the map restricted to F is the identity map, and the image of D cross I is just sending to E cross I. And yeah, this is the main topics. Ortho handle pair means orthogonal two handle pair. Just this picture. Okay, this picture is like that. On F, it's a two handle pair. D cross I, D dash cross I on F, such that the intersection is just like this picture is just intersection of the annuli. Okay, so just the intersection is a square. This is an O2 handle pair. So the surface link F D cross I, D dash cross I over F by surgery on the two O2 handle pair, it's also considered by using the union of D cross I and D dash cross I is just a three ball. Okay? So by using some such a orthogonal pairs surgery is possible. And the surface links, but the three kinds of surface link for orthogonal pairs, but these are all equivalent, and the following property is obtained. Common two-handle property I call. Let F be a surface link in four space, and D cross I, D dash cross I, and E cross I and E dash cross I, the orthogonal pairs on F, such that the attaching part are equal. In that case, if D cross one two-handle is equal, okay, or D cross I equal D E cross I, or E dash cross I equal D dash cross I, then orthogonal pairs are equivalent by equivalence obtained by three cell moves on the union. These are three bold. Okay, so this is today I use this one. So this talk is the following uniqueness is I proved. This theorem is announced in this paper K1, okay, reference K1. But about this topic, it's just something incomplete. Some press. So just I reproved about this result. So main topics is a uniqueness theorem of such of this theorem. It's F be a surface link in four space, and D cross I and D dash cross I and E cross I, E dash cross I, such a pairs, orthogonal pairs, okay, attaching part are equal. Okay, such a orthogonal pair, then such a orthogonal pairs are equivalent. It's a main result. This theorem for trivial surface link is heavily used for confirming the smooth unlinking conjecture, which are completed by this theorem. Okay. Theorem 1 is the reference 1 paper. It's written. It's a surface node F is in four space is trivial if the fundamental group is infinite cyclic group, and the surface link F in four space is trivial if the fundamental group is a meridian-based free group. Okay. Second is a disconnected surface case. So apply to uniqueness theorem. So the proof is divided into the proof of two cases. One is a trivial surface link case, and one is a more general surface link case. And notation is fxj means just usually x cross j, but I omitted of cross notation. So orthogonal pair is now anyway two orthogonal pairs there is. So one orthogonal pair is standard, just considered as a standard orthogonal pair in three space, and the second orthogonal pair E cross I, E dash cross I, such a pair core disks. I consider normal form. It means some deformation of some position of the surface of of these disks is a normal form, I consider. Normal form is just, sorry, normal form is yes, is this written, this paper, okay? And as a, just E and E dash, such a core disks normal form, I consider normal form. But E and E dash is just bound at the boundary is one point intersection there. So just to remove such a such a case to consider a boundary, small boundary color of E dash. It's M boundary E dash, okay? And just to remove of some such a boundary color, which I denote by E dash N. Okay, so consider E and E dash N. It's just disjoint. Okay. So assume now okay, first case is first proof is the surface is F is a trivial. So just assume the trivial surface is embedded in standard ring R0, okay, T equals 0, okay, 0 section, okay, it's 0, level 0, 3 space, okay, it's a R3, 0, okay, and with a standard Otsu handle pair was also there and on F, okay. In this case, the reference KSS, the disk union of E and G is E union E dash N, okay, is deformed into a disk union G1 in the normal form, okay, by isotropy of R4, keeping the trivial link in T equals 0 space, okay, is fixed. And also N boundary color of E dash is fixed and F is fixed. Okay. Okay. Now the normal form. Okay. So this is a E. Okay. O and O dash means trivial links. Okay. This is some kind of in four space. Okay. It's a surface. Okay. In four space. But this is a T equal 2 level, T equal -2 level is appearing disks and T and just before trivial link appearing and T equal -1 level is trivial link appear together with a band, okay, appear and between -1 to 0 it's some link. Okay? Some these links band surgery. Okay, some link occurring, and T equals 0. It's just a boundary G appearing there, and L is some extra loop link there. Okay, and also T equal 1 is a band, new band appearing, and it's some surgery, and it's a trivial link appearing from -1 to 2 level. Okay, and it's just trivial disks D dash is appearing, and it's some such a thing. Main point is of normal form. It's just force coordinate, okay, force axis. Along the force axis, the surface is just straight, okay, along the force axis. It's a main point. Just except for the levels appearing the band and disk. Okay? Okay, it's a main point of normal form. The idea is something is simple, but first, okay, it's a G1, okay, it's a disk union, okay, E and E dash N, and first is deformed to E, not I to B, okay. Anyway, like these pictures, okay, E deform E to just level up, okay, and keeping E dash N fixed, and then okay, E is just level up. Then also handle pair. So a common to handle property there is. So just default of and next is E dash N. And consider this is a starting point. Okay, starting disk union. Okay. Then okay, next is E dash N is deformed. These pictures. Okay. While keeping E is fixed, and then apply common 200 property. Okay. So such a deformation is an idea. So but to obtain G1 is some observation is needed because a starting point is t equals 0 level. Okay, it's given. Then just upper four space. There is a normal form. Just considering in that case, a minimal disk there is in the upper case. So need to pull down to the lower four space. Okay, so pull down. And next is a lower for half four space. It's appear maximal disk appearing in the normal form. But so pull up the in that case. So in the level t equals 0, some trivial loop increase, but no problem of some such a link considering first. Okay, and also that deformation is a very standard argument of normal form, and also the very standard argument of normal form is a band system made disjoint. It's by seam band and some such a thing. Okay. And considering G1 of such a normal form, and the restrict to E. Okay, disk is DE and restrict to the disk system. E dash N is just D cap D E dash N. Okay, some also a band. Okay, band appear coming from E is B E, and coming from E dash N is B E dash N. It's a band system. Next deformation is to change the level of the band system to -1 level. Band system -1 level there is okay. Is level up. It's B okay 1 okay. Because other part is just straight for force coordinate. So no problem. Only these band level and the disk level only changing. And so disk level D minimal this D means a minimal disk. Okay, it's a level is into 0.5 level, just a level up. To do so there is a there is a some deformation is needed. It's a boundary of surface, the loop, okay, boundary G, and the boundary system meets a disk system in finite interior point and in finite simple arcs. Okay, so just in this case, this disk, okay, just such a force coordinate product structure is just considering it's easy to DE is deformed to first to get one more to get yeah to get yes this no intersection, okay, some E is deformed to E tilde intersection. How to get intersection of the disk and intersection? In that case, E, okay, E is just to remove the disk, okay, intersection. First is draw a line to the boundary and neighbor taking and replace just to remove these disks around the neighborhood disk. And it's a product structure. So just to deform is possible to surface E is deformed. So it's called E tilde. Okay. Okay. First is okay. E tilde and boundary E, and second is band and B E dash N, and also E is must. There is some intersection arcs there is, but also some arc to the boundary drawing, and it's such a neighbor is removed. Okay, so E tilde is just only E tilde is deformed, and to get this no intersection, okay, situation. But in that case, this is an important point. E tilde may intersect F. Okay? F is a level 0 surface, but so my deformation does not need isotopy. Does not need isotopy. Isotopy is not needed. So only ortho-handle pair. Okay. So common two-handle property is only very important. Okay. So it's so possible. Anyway. Anyway, surface, okay, it's just deformed of this one. Okay. In this case, in this E, okay, in this case, okay, E tilde cross I and E dash cross I, the pair is also handle pair, and E dash cross I is the same one. So original, okay. Common to handle property. This handle is equivalent to the original one. Okay, so just to consider this one is the original one. Okay, and the second is also very similar to just this case is E dash N is just deformed. E dash, okay, Next is E dash N is just deform is needed. So just in this case, sorry, in this case D dash N and boundary G. Okay, there is an intersection. Also, very same method is deform D E dash N is just deformed. Such a minimum disk is just deformed. E dash n to get okay. So to get okay E dash n deform E dash n tilde is just boundary E and boundary E dash n. But it's a not very small color. Okay, boundary color there. So it's not also not no intersection. Anyway, now in this change the level of the bound system into bound system is level up and the disk system of -2 level is just the resulting okay G3 is just like that. So just level 0, okay, only just a circle only, okay, boundary circle only appearing. So E cross I, E dash tilde cross I, and with the boundary color joining, it's also handle pair on F and equivalent to the original handle by common two handle property. So just situation is just one D cross I, D dash cross I is just level 0, and other two handle is just upper half space in there. So this means the pair D cross I, E dash cross I, and anyone, okay, it's also handle pair. So common two handle property, D cross I, D dash cross I, and E cross I, E dash cross I on F are equivalent. Okay, main point is just okay. So this deformation is okay. If there is a level 0, okay, and F is some deformation is intersection, but this level is just up the level, up the okay positive okay, it's the upper half level, just moving. This does not ambient isotopy, okay, because F is just interrupt. Okay, so but the auto handle pair is this one and this one is just auto handle pair is okay. So the this is the main point of this argument. So general surface case, general surface link case. In this case, okay, in this case, okay, it's some technique. It's a general surface link in maybe just D cross I, D dash cross I, some surgery, first surgery, okay? So surface link F D cross I, D dash cross I, considering. So some such a surface bound 3 micron, okay, connected Seifert hypersurface bounded of the surface link. Okay, and E dash is just intersect as a group. Okay, no boundary is no intersection of the boundary because boundary is D cross I, D dash cross I surgery. So no intersection of this one. Okay. So E and E dash it's avoiding the roots. Okay. So some 100. Okay. It's a so 3 manifold. Okay. Bounded 3 manifold. In that case, 100. Okay. 100 removed. Okay. Some kind of 100 removed. Then we'll get 100 body. Okay. We'll get that is a 100 body boundary is a trivial surface knot. Okay. So some such a 100 is considered in W, okay, attaching 100 to if this. So so this means there is a trivial torus of T in such that the connect sum F dash sharp T, okay? Connect sum F dash and T. It's a trivial surface not in R4 obtained from F by surgery along the one hand HJ, and D cross I, D dash cross I, it's a standard also handle pair on F dash connect sum F dash plus T, okay, attached to the connected sum and T, okay, attaching part is some, so construction of the pair yeah, okay. Okay, okay, this, okay, okay, connect sum, it's a defining four ball, okay, about the connect sum and T surrounding. So that means, okay, one handle on F, but here is two handle, just changing the one handle is just changing here, it's a two handle, F dash connect sum T, okay? And attach, this HJ is a two handle on F dash plus F T attached to F dash, okay? And okay, and HJ is it's a disjoint from the defining four ball surrounding T. Okay, so all the H is a core disk system of the two-handle system on F dash sharp T. Okay. So trivial surface link case, the argument also handle pair E cross I, E dash cross I is equivalent to D cross I, D dash cross I on F dash sharp T. But okay, such a equivalence is without crossing the core disk. Such a result to obtain, the proof is revised as follows. Normal form of the disk union, okay, E dash N and this two handle, okay, is written G bar, is like that, and G bar is okay, but the G bar important point is the G bar is just does not intersect with the boundary G. Okay, boundary G means okay. Boundary G means okay. Not to include H. Okay, boundary G because the boundary G is in the okay four ball. Okay, disjoint from two handle. Okay, some four ball inside there. So idea is also the first deform E and while keeping H 200 core and E dash N is fixed and apply the common 200 property and then deform E dash N while keeping E and H fixed. And then applying the 200 common 200 property, so we'll get the result. It's an idea. Okay. So OH is a trivial link disk and band and okay and link. Okay, these are also occurring in normal form. Okay, sorry. Yes, so Yeah, okay. So applying here, okay, applying here this one. So the same method. Okay, first is E1 is just level up, and it will get this this normal form. Okay, and also second also it's also a second also taking a normal form. H is only H is unchanged. Okay. So obtained obtained is so obtained, yes. Yeah, obtained is a D cross I, D dash cross I. Okay, also handle pairs equivalent under three cell moves disjoint from the two handle. But one more. Okay, okay. F dash connects some T. Okay, such a part. It's a just also handle pair, just equivalent. Okay, equivalent is just proved. Okay, and the also handle pair. Okay, it's a disjoint from the two handles. So just the back surgery from F dash connect some T to F on two handle. This means also handle pairs are equivalent under three cell moves disjoint from the one handle on F. Okay. So this means just general case is also proved. This. And the next is considering an immersed version. Okay. Immersed version is for recovery lemma. If D cross I, D dash cross I is an immersed also pair, also handle pair on a surface link F in four space with D cross I immersed and D dash cross I embedded. Then there is a embedded two handle D star cross I with boundary is equal to the boundary of D cross I, boundary is equal. Such that D star cross I, D dash cross I, such a pair is an O2 handle pair on F. So immersion, but immerse double point is just removed. So this lemma is it's just a finger move canceling. This means that some disk in four space and two sphere attached to one point. Two sphere attached to one point of this disk. This disk is immersed. In that case, a double point there is. So under this point of two sphere point, okay, this both normal disk, normal fiber disk of some line on the disks. Okay, so just a fiber tube there is, and to get to use this two sphere, we'll get a new disk. Immersed disk is obtained, but the double point is just one double point is reduced. So continuing this process, it will get a new embedded disk. It's a finger move canceling. So a recovery lemma. It's how to get it's a one hand, okay, it's a 100 100 embedded and other immersed 200. In that case, so embedded 100 is just squeezed, okay? It's just shrinked as a like a line, okay? Very small solid tube inside. In this case, some two sphere intersection at one point intersection, transversely one point intersection. Some such a two sphere is obtained, and some such a cancelling is possible to get, and we'll get embedded these 200. So that is the idea. So corollary is so also handle pair or D cross I, D dash cross I, and E cross I, E dash cross I immersed also handle pair, but on F with a boundary, okay, on a surface link with boundary is the okay same equal boundary. Then if D cross I and E dash cross I embedded, then there are embedded 200 D star cross I and E star cross I on F with the boundary same one, such that these pairs are equivalent O200 pairs. So that the F D cross I and F E dash cross I, some such a surgery the surface link are equivalent. Similarly, if D dash cross I and E cross I, so in this case, different part, okay, different coordinate, different part is embedded. It then is very similar. There are embedded 200 D cross I and E dash star cross I, okay, D star cross I and E dash star cross I embedded with such that the pair is also equivalent to O200 pair. So FD cross I and FE cross I are equivalent. Okay, it's my talk is finished. Little early.
Hey, thank you very much for interesting talk. So we have time for questions, so please, questions, welcome. Yeah, essentially I have two questions. One is maybe stupid question. You taught about orthogonality. So what it means in your context? Please explain again.
Sorry?
In the title of your talk, you consider orthogonal two-handle pair.
Yes, orthogonal 200 pair. Yes.
Yeah, yes. So please repeat what means orthogonal in your sense.
Orthogonal, yeah, it's orthogonal means wait a minute. Yes, first. Yeah, right.
It's just transversal or not?
Sorry. Yes.
It means transversal.
Yes, transversal, but okay, 200 is only intersect. Okay, 200 only intersect of the boundary. Okay, boundary annulus is just just intersection only a square. Only a square. Okay.
Okay.
200 and 200. Okay.
Okay.
This is yes. So this means in surgery theory, I mean, usually surgery theory is a complementary pair of 200. For example, P200 and P plus 1 200 is complementary.
Okay.
In that case, in that case, cancel. In 4-dimensional, this is very critical. 200 and the complementary must be 200. So such a general surgery theory is go well in four space. I mean, some such a thing. 200 and 200 is just a complementary pair.
Okay, thank you very much. And another question, maybe not related directly to your talk, but can you say something about geometric structures related to surface links? Are there some results about the geometry of this object? Can we introduce geometric structure related to this object? Maybe you know some results, or maybe you can suggest some reference.
Geometric structure means I don't know what means.
And for example, in the three-dimensional case, we have a lot about geometry of link complements. Yeah, I mean, in this sense, is there some results or some studies?
I don't know. I don't know. In four-dimensional, yeah, it's a infinitely many geometry. It's a
Yes.
no, yeah, four-dimensional.
Of course.
No. Here is no only smooth category only, but the smooth structure also. I don't know the. Yeah. Yeah. It's maybe almost in this case, it's a combinatory piecewise linear case. It's almost equal in my feeling. My argument is.
Okay. Yeah, thank you very much. Please, more questions, if any.
Thank you for interesting talk. It's very nice. I have the following question. In the classical case of a one-dimensional node, we can present any node as closure of a braid. And for surface links, I know a similar technique that it's possible to define two braids and consider their closure. My question is the following. Is it true that we have finite number of generators and finite number relations for two braids? Is it true or not?
Two braids. You mean two braids, two-dimensional braid? Yeah.
Yes. Yeah. Because for classical braid we have Bn. Braid group of n strings, we have finite number of generators and finite number of relations. Is it true for two-dimensional braids?
I don't know because it's a normal form is very related to some such a braid, but I don't know. It's maybe. You should ask Kamada.
Yes.
Sage Kamada will be.
Oh, yes. May I answer your question?
Yes.
Yeah, sure, please.
Yes. The set of two-dimensional braids forms a semi-group, not a group.
Yes.
And as a semi-group, it's infinitely generated, not finite.
Infinite, but the number of generators is countable.
Yeah, countable, but infinite.
And is it possible to write the full set of relations?
Yes.
It's possible to define the set of generators and relations. Okay, thank you. Yes, I remember that in your book it's possible to find. Thank you.
Thank you.
Thank you very much. Please, more questions? I see you have interesting discussion, so please, some more questions, opinion. Okay, if no, so let us thank Professor Kawauchi again. Thank you very much for your talk.